Gamota is a critical infrastructure pioneer with over 30 years of U.S. and international experience, achieving results for critical infrastructure business and executive, ownership, consulting, and board roles, leading to over $4 billion in value. Since 2023, he has served as the CEO of 3PO Networks, which is based out of Roseburg, Oregon. Alex has a broad background in wireless communications, traditional utilities, infrastructure financing, deployment, and operations. He has had prior roles with American Tower, Big Belly, Light Tower, SpectraSite, Transco, PRTM, and the MWRA. He is a frequent panelist at industry events and a contributor to trade regulatory activities. He's a longtime volunteer on local community issues, academic mentoring, and Ukraine. He serves as the president and co-founder of Bear Witness and an advisor for the Center for Civil Liberties. He received his bachelor's degree in economics from the University of Michigan and earned his master's degree in city planning from the Massachusetts Institute of Technology. If everybody would join me in welcoming Alex Gamota.
Good morning.
Good morning.
So I'm a former coach of my kids' team, so I didn't hear anyone. Good morning. Good morning. One more time. Good morning. All right, great. Well, good morning, and it's been quite a week. And so one of the things I wanted to do was have this be sort of a light conversation. We do have a presentation that I'll go through, but if at any moment you have questions, please feel free to stop me. But before I start, has everyone who wanted to participate in the trivia submitted their answers?
If you have a ticket, hold it high. I move to close the.
Okay. All right, so the answers, and what we'll do if there's more than one person who has it right, this bucket, Michael has the honor of pulling out the pieces of paper, and the first one with the correct answers is the winner. So unfortunately, well, we're all winners, right? Unfortunately, there's only one gift card.
Should we embarrass the people who are wrong?
Especially since I know the answers.
Sure. So, who thought Rome? Who thought Egypt? Pakistan? Mesopotamia? None of the above. Okay, good. It was Mesopotamia. So, and it's not cesspools. Oh, that was a great question. It wasn't cesspools. I mean, these were legitimate with pipes, using gravity sewer, taking it away from people's homes or buildings. Question 2. Who thought 5 feet? And these are for city sewer mains. 10 feet? 15 feet? 20 feet? 25. It was 25. Yeah, they can go down quite a lot. Because again, I mean, you're trying to use gravity. So, Michael?
I'm trying to find a winner.
You have a winner.
Yeah, okay. I went to the honors. Okay.
Okay, so we're going to do the honor system. The winning ticket does not have a name on it. Is that
He said he forgot to put his name on it. He said,
Right. And how did you answer it?
Okay, so Mesopotamia.
Well, no, like, how did you write it? Do you remember?
Q1, Q2.
We're doing handwriting.
If you look at my crap handwriting, it's shitty handwriting. You see. You need, no, that's not me.
Can you rewrite your answers so we can match it?
No, it wasn't me.
you weren't alone. You got to put your name on it. So look at that.
All right.
That's funny.
So, So, just by show of hands, who came here to hear about fiber networks? Okay. Who came here to hear about wastewater systems? Who came here to hear about both? All right, great. So, most of my career has been with telecommunications. I started life at the MWRA, the Massachusetts Water Resources Authority. Is that better? All right. Is that better? Yeah. Okay, great. So I started life at the Massachusetts Water Resources Authority, as Michael alluded to the MWRA. And out of the MWRA, there's plenty of folks here on the Cape who have a legacy or alum of that organization. But I quickly got into wireless infrastructure back in the late 90s. So if you remember the late 90s, there was all sorts of questions. Hey, is a cell phone really for real? I mean, I don't know if people remember that. Because I remember when I left traditional utilities and joined a tower company, my parents thought I was crazy. What? That cell phone? No one is going to use it the way people are saying they're going to be using it. And obviously today, wireless is so much in our life in so many different ways. And I only want to bring this up because the regulatory and the business models and the whole ecosystem associated with wireless infrastructure and then also fiber really has changed dramatically over the last 20, 30 years. And in fact, American Tower at one point almost went bankrupt. If you remember that back in the early 2000s, today it's the largest publicly traded real estate investment trust. So I wanted to first start with the sewer stuff because the conversation for 3PO networks is actually led by sewer, and that enables fiber, as you'll see. But the thing that really makes this exciting for me as we go to market is the housing, right? Because across this country, there is a crisis of lack of housing. There's 1.5 million homes built every year. Hopefully that still stays the same. But there's a range of 3.5 to over 5 million homes that won't be built. And this is according to Jerome Powell, who's a pretty smart guy, because of, these are workforce houses, and it's because of things like lack of land, maybe it's zoning. What we believe is that there's a certain percentage of it, and I think that's the case here in the Cape as well, that the projects have stalled because of wastewater treatment deficiencies. And certainly our first projects that we have in our pipeline are these types of projects. Those developers found us because we've partnered with a company called Orenco out of Oregon. We have Orenco here today as well to answer any of the really tough questions, as well as our partner Atlantic Solutions, who is their dealer here for the Cape, the service provider. We have a way of unlocking these projects, and we'll get into how, that further allow us to build fiber to those homes for day one. So there's a lot there. We're focused on housing, new housing, in particular those projects that have stalled, and we want to unlock those that have stalled because of lack of wastewater treatment through technology, whether it's Orenco, the fiber. And the reason why the fiber is important is because we want to own and operate both of those pieces of infrastructure. And in some cases, that might mean that we'll own the treatment as well. So to have the audience still with me?
Yes.
Okay. So the Orenco technology is really exciting because what it does is it reduces the demand on the treatment plants. And we're going to go into a case study with a project out in Oregon where it'd been sitting there for 4 or 5 years, and the treatment plant was near capacity. But by doing this approach, we were able to basically get the the will serve letter, because we're putting in 50% less of the effluent. The effluent has been pre-treated, so there's kind of less to treat. It's cheaper and faster. Part of it is that we're contributing capital to the developer as part of this, fully compliant with the environmental, local, state, and federal. While you put this in, you run another conduit for fiber. So day one, we have these two distinct networks, but there's a lot of synergies both in the construction, using the same crews and approaches, as well as even on the operations side. So jumping right into that case study, has anyone been out here to the Olympic Coast? Great. So you know how beautiful that area is. And with COVID, a lot of people, and this might sound familiar to the King, a lot of people realize that, hey, I can work remotely and I can enjoy this beautiful, beautiful nature. And by the way, I don't think I said, well, the company's based, headquarters is Oregon. I live in Cambridge, Massachusetts, so I'm just up the Route 3. But I've gotten to love the Oregon, the state and the coast in particular, and really appreciate the challenges that they have. Because right now they have a very low vacancy rate. They're losing teachers, nurses, and they haven't been able to approve new developments because of this wastewater treatment issue. This project in particular, the 450 unit workforce housing, was on hold for many years. This is a view of the site. You can see the Columbia River over there, and then over here to the left you can't see is the Pacific Ocean. Really, really beautiful. This was taken back in the fall. They had just started after they had gotten their permission for the sewer.
Quick question, is this for residential or is it just in the country?
Sure. It's for non-urban environments, is a great way of thinking about it. But it could be like exurbia. It could be like this area, resorts. The Orenco solution could be individual homes. It could also be, thousands of connections for like kind of a exurbia, suburbia kind of situation.
I was just trying to think of how, because I came from construction, so I'm picturing a sewer line and then a fiber line next to it. How do you connect everything? You have to go over one of the structures, so.
Sure. We have a picture. We'll get right to it, John. So this is a little bit of what I said earlier, that we were able to unlock it by using the Orenco's pressurized liquid-only sewer technology for collection. So this is just collection, not treatment, because there's less effluent to treat, and the treatment that's required requires less treatment. For the developer and the community, it reduced the developer's sewer cost, again, the collection part, by 65%. We contributed capital. We had a design budget within a couple of weeks. We're providing the turnkey sewer operations and maintenance. And we're taking the approaches I mentioned about American Tower, mentioned about some of the other experiences I have with large owning, maintaining infrastructure. Our team are people like me that have that kind of experience all over the country.
Just a question here. So you're basically promoting the utility model. So you guys act as a utility.
That's correct. That's correct. The regulatory is different by each state, what kind of status we need to have, but we're a private company. And then last but not least is that dark fiber, because we're not a ISP, would be ready at the property day one. And typically what we would do is we would talk to local ISPs that would be interested in providing service day one. But as a dark fiber provider, we'd be talking to all the different ISPs. And that's the team that 3PO and the developer. You can see me there smiling in the background. So a little bit about Orenco. I don't know here how many people have heard of Orenco. Great. And I know that there are different innovative alternative kind of sewer companies and treatment companies, and I'd welcome any sort of questions about their approaches compared to this, and whether if I can't answer it, Mike or Bob could. So they've been around since 1981. 400 employees. They're a U.S. manufacturer, and they have a nationwide dealer service provider network. And as I mentioned, Bob, and we just met Mike, right?
Yep.
Yeah, Atlantic Solutions, that's the local one here for the Cape. They have tens of thousands of deployments all over the world. This, as you can think about it, not only in the US, but places like Greece or Australia. Think about kind of coastal resort, eco-friendly areas, and this is kind of the big part of their sweet spot. They're focused on passive, scalable, and economical solutions. Industry leader, liquid-only sewer. And then, notably, they were purchased last year by ADS, a very large company out of Ohio, Advanced Drainage Systems, publicly traded, who Newsweek for the last 3 years has called them one of America's most responsible companies. So the approach that Orenco takes, and we're not going to necessarily do a deep dive in every one of these aspects, but when you think about sewer or wastewater treatment, there's sort of three different aspects. There's the collection, there's the treatment, and then there's the dispersal. And so what this shows here is an area where you have single-family homes, you have a multi-family unit, or it could be a school, and you have in front of the homes in the buildings a unit that actually does decentralized pre-treatment. That then goes to a pipe, a 2-inch or a 3-inch pipe that goes to the public right away. And we have some other photos as well that we can show you that then goes to treatment. Now, if in the case of Warrenton, that 2-inch pipe went to the municipal main, and then the municipality does the treatment. And some of the projects that we're looking at, we're actually going to be doing the treatment on site. If you're doing it on site, and that's there on the kind of 2 o'clock, then the question is, well, is that sufficient for the local environmental requirements? Maybe there's a little bit more treatment that you need. And then the question is going to be, okay, how do you disperse it? And dispersal could be, underground, it could be irrigation. We're talking to some ski resorts about making it available for snowmaking. We're talking to some projects out west and having it available for fire suppression. We're even talking to some areas that they're using for data center cooling. So lots of different ways of dispersal, but what I really wanted to focus on here was more about the collection aspect of this. So far, so good?
Just because of the beginning of our gravity question, this isn't gravity, this is all powered by electricity, correct?
That's correct.
Okay.
That's correct. Well, and I'm glad you asked that though, because with gravity, we think it's just gravity, but in fact it's not, because gravity only works so well, and I think that might be the. See, I have a slide right here. I think that does a great job. Gravity's there on the top right, and at a certain point, in certain situations, you need a lift station, which will need electricity. And the other aspect of lift stations is obviously the cost of installing the lift station. And then the repair, the maintenance, and all those things. Where with liquid-only sewer, which is the top left, just follows the contour of the land. And it just needs to go below the frost line. So, John, to your question, imagine a trench. Again, you need to follow the code, but you would put the liquid-only sewer collection line in below the frost line, and then whether it's horizontal separation or vertical separation, you'd put in the conduit for fiber. Probably some of you recognize the grinder or vacuum. Those are some other technologies that are out there. And we'll come back to kind of pros and cons with each one of them. But did that answer your question? So this is an illustration of what it would look like. Again, decentralized pre-treatment with that unit on the property that then connects to a small diameter pipe in the public right-of-way. There's no manhole covers, there's no lift stations. More importantly, on the treatment side, there's no headworks required, because all the solids stay right there in that treatment unit.
Quick question, are you still using it, say at the individual house, are you still using like a 1,000 gallons septic tank, your holding tank, and then treating with it, because it used to be the Orenco Advantage, if I remember.
So this isn't the
holding tank and then into the
right. So this isn't the Advanix, but
it's using something else.
right. This is it's like a septic, but it's a better process there as far as treating the solids that would reside. Pump outs typically, would you say, Mike?
Target 10 to 12 years.
Every 10 to 12 years. That would be part of the 3PO model that we would cover that cost. And then if the Advantex, if that was part of this, that would be somewhere on the development, but away from the homes. Because that would be treatment already. That'd be secondary treatment.
You offer a treat for water use on site.
So the PreLOS units are the collection and provides primary treatment. So unlike a grinder pump where you're putting it into a slurry, functionally it's going to behave just like a septic tank does. We're doing what a septic tank does really well, is provide 60% of the treatment before it leaves the site. Solids are retained there. Anything that will float, and we're just pumping from the clear zone in that tank. And then from there, that collection main can go anywhere you want. We can pull off it with decentralized treatment. We have systems going 10 miles to the nearest treatment plant.
So it's where pre-treatment, right? Pre-treatment before you go actually to the,
That's right.
to the source and stuff.
Yeah.
And how many milligrams per liter do you get it down to?
So typically coming out of this unit is about 140, 130 milligrams per liter BOD, 40 TSS. Fats, oils, and grease are less than 20. Not a whole lot done here for nitrogen that's done at the final treatment.
And on that, I mean, Mike, put back this slide with the 4. I mean, if you, I don't know if it's an eye chart, but the waste strength that comes out of each one of them, you can see that with the liquid-only sewer, which is the top left, you have reduced waste strength coming out just from the tank there as a pre-treatment. Yes, sir.
Yeah, chemistry was never my strong point, but how do you assure that the nitrogen doesn't end up going right into the soil and we have the problem we currently have?
So everything first is designed to be watertight. So there is no I&I in this. There's no exfiltrate. It's all sealed. All the pipes are high-density polyethylene pipes fused. So all of those then go to not just to a drain field. They'll go to, somebody mentioned Advantex. Well, in our case, we'll use Advantex decentralized, or it can go to an existing centralized plant where we would be managing nitrogen there. So depending on what our target is, if it's ammonia or nitrate, we'll design the plant accordingly.
So they get into the liquid.
Pardon me?
So you get those into the liquids. So
They will, yeah. There's nothing, at the PreLOS, there's nothing there really to reduce the nitrogen. So that's going to occur at the decentralized or centralized plant.
And that's a great question, because my understanding here on the Cape that some communities have started investing in treatment facilities. So if we were to do a project here, we would want to try as much as possible to connect to those facilities and reduce the nitrogen as it's being done for any other effluent source that gets entered into that system.
Just drive around with it, you'll see the roads there.
Sure, sure.
So what are the size of the tanks relative to existing septic tanks?
Sure. So you can see the shape's a little different. It's actually designed as a meander tank. What that means is, that's why it's circular, is the flow actually goes to the far end and back, and the reason being it increases the flow path for solids to settle. The smallest tank is good for up to 4 bedrooms. It has a 1,000-gallon liquid level, 200 gallons of freeboard in it, and dimensionally it's about 7.5 feet across and about 6 feet tall, and then the riser is used to adjust to whatever depth we need the system at.
Was it mentioned that they need to be cleaned out every now and then or replaced?
Yes. So one of the fallacies with septic tanks is that you have to pump them every 3, 4, 5 years. That's usually a regulatory requirement, and the reason you do that is you have to manage the worst case scenario. So if you had 5 people in a home, you don't want solids to get out into a drain field, so you regulate what I would say is actually a premature pump out interval. In these systems, because they're professionally managed, you want to keep the solids there for as long as you can. So you actually come out every 3 to 5 years, and instead of pumping the tank, you measure the sludge and scum. Especially if there's only 2 or 3 people in a home, you're going to find out that you don't need to pump it, and you just keep pushing that out. So on average, we target 10 to 12. If you have 5 people in the home, you're probably going to be doing it at that 3 to 5 years. But if you have 1 or 2 people in a home, it's going to go out 20 and 30 years.
How deep is that?
So like I said, the tank itself is about 6 feet. The riser here is going to be probably 24 inches, I would say.
But a septic truck doesn't have to show up.
So only when the operator says, hey, so we pump it out when the solids get within 6 inches of the inlet into the pump. All this have to be pumped out. They can, yeah.
Tank is composite?
So it's made out of a resin, it's a resin-based product, kind of looks and feels like fiberglass. It's DCPD. So you can Google that to see the long form. I'm not going to embarrass myself by trying to say it. Kind of embarrassing that we make it and I can't say the long form of it, but DCPD. But when you look at the tank, you'd actually think it's fiberglass.
Alex, bringing this back to what you originally started with for context. We have a housing crisis, and one of the issues is the fact that we're having problems permitting for wastewater and environment.
Right.
Where do you guys get brought into that process? Are you brought in by the town? Do you advocate on your own? Tell us about the business aspect.
Sure. Thank you. Although certainly we can talk about sewer as much as we want. But from a business perspective, the way our business has been rolling out, developers have actually been coming to us because they've been sitting on property for 3 years, 4 years, 5 years. They have maybe an initial PUD approved, you just don't have their sewer will serve letter. And we're able to show them, and then they bring in the city that, hey, there's some capacity. Maybe there's even a plan for the city to get more capacity, but that's contingent on them raising a bond, getting money, and then building it out. So here's a way of actually unlocking it sooner and faster because we're showing the developer, and more importantly the city, that we're gonna fit within the envelope of how much capacity you have left in that treatment. In some cases, we're talking to people in a county, think of down south, where the county doesn't have sewer. Typically, the city would annex that area so that they would have treatment. Well, they've run out of treatment. And so we're talking to these developers in these counties saying, hey, you can be off-grid and do not just collection, but also treatment on your development. And we're also having, as you can imagine, certain states, the governors have been very, very active around housing. Oregon is one of them, and so the governor's office heard about what we're doing, and they actually have a team within the governor's office of economic development people that are aware of all these projects across the state, and we've been pulled into different conversations that way to say, hey, is this a way of unlocking the project?
it's not 100%. I mean, this is not the silver bullet for every project, but you know, certainly right now it's trending sort of 30 to 50% in our favor.
Thank you. So, since you live in Cambridge, you know that all of us in Massachusetts have an environmentalist angel on one shoulder and a construction devil on the other shoulder, right? And that's a battle that we all face in our hearts, right?
Right.
We'll put that battle aside.
Right.
So, do you have, you showed us the beautiful bluff there.
Right.
In Oregon. Do you have more, what does the plan look like? Can you tell us more about that case study, please?
Right. Huh. Looks like the slide with the development didn't make the cut. Right. My apologies. I don't know how we lost that slide, but it's this is 77 acres. It has approval for 447 units. 210 of them are multi-family. There's about 33 townhomes, and then the rest are single-family homes. The multi-family is workforce. It'll be owned, managed by a private company. About half of the single-family homes will be sold. HOA will be created. The other remaining will be under a build-to-rent company.
Have you broken ground yet?
They will break ground this summer. They've been clearing it. They've gotten their will serve letter. There's like any sort of construction project, there's an environmental piece, not this site, but to connect this to the treatment. It's going through wetlands, and so they're waiting on that.
My last question, I promise.
Sure.
Have you done any projects in Massachusetts yet?
We have not. That 3PO, as my prior life, many projects all over the place, including on the Vineyard, Nantucket, some very contentious siting, if you will. And then for wireless, but Orenco, there's a great deployment that they have up in Gloucester. How many units is that at this point?
I'll say it's close to 1,000.
Yeah, about 1,000 of those units are installed, and the relationship has been 15 years?
Longer than that, yeah. 20.
20 years. But going back to, the business side of it, we're helping unlock these projects for the developer, because there's the business side of it. It's a increased ROI on a project maybe that would be stalled indefinitely. The design, because we're not going down 25 feet, there aren't lift stations. The engineering associated with it is a lot less of a heavy lift. Obviously, there's still soils and things you need to think about, but certainly we're able to, with Orenco's support, produce proposals very quickly, and it's also on our nickel too, which is a little bit different, I think, than some of the other approaches.
So I have a question about that. So if it's not, you don't have lift stations.
Right.
So does that mean that the pipe is pressurized?
That's correct. That's correct. I'll come back to that because there's some benefits associated with that I wanted to cover. We're delivering more value because we're bringing fiber to that premise day one. We're just following the lines of the collection system, from the meet point down the street, the lateral, the tank. The tank actually uses the fiber for telemetry, which also has some pretty interesting benefits. And then we're running it to the home. And then simplifying, because one of the challenges that we've heard about doing something that's non-standard, because this is non-standard for a lot of people because it's not gravity, is who owns it, who maintains it, who does the pump outs. And that's something, given our backgrounds in operating, maintaining critical infrastructure, we take on, for 10 years, 20 years, however long our contract will be with the folks. And there's a lot of interest from the business side in those kinds of businesses that are able to operate, maintain assets, and from our perspective, we're maintaining two distinct assets with different revenue streams. So, the fiber side, which we haven't really talked much about, having an anchor tenant, because that's how you call it from the fiber side in sewer, and having service people that are cross-trained on maintenance for dark fiber, for the sewer, certainly there's a lot of synergies and benefits with that. And our plan, quite frankly, is to take a page from the American Tower business model, where they don't have an army of ops people. What they have is they have a network operating center that's able to see the status of their assets, that telemetry that we talked about, right? We can see how the pump is operating and if there's anything kind of suspicious with it, right? And then, like here, we'd be working with Atlantic Solutions to get a guy out there if need be, right? Otherwise, it'd be Atlantic doing the preventative maintenance both on the sewer and for the fiber. But because you have telemetry there, not only do you have that visibility, but I'll bring up a sore spot here, but Cambridge has the same issue. We have above ground power lines. And so we get a nor'easter and we're out of power, okay? So twofold. One, because you have that unit there, it has storage for up to 3 or 4 days, right? So usually when you don't have power, you're not gonna be doing your laundry and other sorts of things, but you will be still using the toilet, right? This has that storage there for those 3 or 4 days. More significantly, if we know a nor'easter is coming, we can just proactively tell that pump, hey, pump out now, right? So that it's more or less has the full capacity available for that storm that's coming up. Yes, please.
If you connected, instead of the tank shown here, to an innovative alternative unit that did more chemistry treatment, we're working with a lot of different providers that are trying to develop nitrogen reduction,
Sure.
phosphorus reduction. I would guess if we had the appropriate chemical monitors, you could have that also monitored with your telemetry, right? The chemical
Well, absolutely. Absolutely. I mean, I think having the fiber there,
is wonderful.
right. I mean, there's a lot of different uses for it, whether it's commercial or for public health. And this is a way of getting the fiber underground, right? So it's weatherproof from that perspective.
How about also, there's a network of something like 1,600 municipalities that do sewer sludge testing for infectious disease epidemiology.
Sure.
Early warning system, and it was coordinated through CDC, who knows if it still exists, but in any case, there's an amazing amount of information that could be shared.
Sure. No, you're right. I mean, just to add, there's HIPAA concerns, but no, it's something that we've started having some conversations. We'd love to talk maybe more about possibilities. Because I think having first and foremost, it's half the cost of gravity sewer. I mean, you have to remember that. And so this is a cheaper way of getting sewer into communities, and it's faster. But then because we're putting in the fiber, it has that benefit, but then it has the public health and the community benefits that we really haven't explored at this point, but we know that all exists there. And then last but not least, because sometimes power outages go more than 4 days, it does have a 110 volt jack on it, so you could run a generator to pump it out if we need to.
Can I keep us, you're in a gravity system, you're no longer a powered system. Let's say you get hacked. I mean, you talked about critical infrastructure, are you gonna address that? I mean, is it, the vulnerability, even though you are a dark fiber, you're not touching the internet
Right.
by your digital infrastructure, that is a concern.
Sure.
Because that's a priority number one for all the guys doing mischief, you know, for these
Sure,
nation state
sure.
weapons. Have you guys already anticipated that or had to deal with it?
We've anticipated it, and yeah, I mean, I think the thing to look at this is that we're not inventing anything new here. We're just going to use the best in class that's available. Even the knock I mentioned. I mean, day one, it's not going to be our knock. We're going to be being white labeled off of someone who runs this for other companies that where security, cyber attacks is a concern. As far as the other internet service providers, I mean, all of them, I mean, will have their level of ways of sort of ring fencing, you know, theirs, because they're just leasing strands from us. So there shouldn't be a way of contaminating, let's say something goes wrong with them, and the unlikely event of jumping into what our network
But it
is.
sounds like you've integrated, so you can do diagnostic checks remotely and everything. So this is really, you know, 21st century stuff that you've developed here. So
That's correct.
It is right, you know, from.
Well, again, we haven't developed. I mean, this all exists. It's just we're putting it in a business model that's a little bit new. There are places that have run fiber with sewer, so that idea is not completely new. I think our packaging it where we're doing sewer, Navy treatment, fiber, owning and operating, and contributing capital. To our knowledge, there's no one out there that's doing all that right now.
I have a follow-up question on the pressurization. How do you pressurize this thing? And what if, you know, the thing about gravity is that, you know, it's going away, right?
Right.
But with all of us with septic systems, we've all had the situation where
Sure.
something gets clogged and it backs up.
Sure.
How can you prevent backups into homes, you know, if something goes wrong?
So the pump, you don't really see it in that graphic. If you're familiar with pumps at all, it's a turbine pump, similar to a well pump. Best way I would describe it, you can see it there. The bottom of it is a motor end that powers the impellers. Liquid goes in the middle. Above that is an impeller stack. Very, very efficient pump. It's. I mean, for anybody who's familiar with pumps, it's a very vertical pump curve, which means that it doesn't vary very much how much is coming out of the system, and it shuts off at a very high pumping head. So when I say pumping head, it's 230 feet. That means if I had the pump on the floor here, it could pump 230 feet straight up in the air before it deadheads.
So you're pressurizing at each system?
We are,
So
and
you're
it's-
pushing out always?
Right, and then
Okay.
it has to go through, there's actually a check valve in the pump, there's a check valve at the top of that discharge, and then there's a check valve at the main as well. So there's really no way the flow is ever gonna come back into the tank. So the only flow you're contributing is from your home. If for some reason that system's not working, it's going to alarm. So there's two floats you can see above the filter. The bottom float there is an on-off, so that's basically just the one that's turning the pump on and off. The one above it is an alarm. It is also redundant on, so if the bottom float fails, the top float's gonna try to turn the pump on, but it's gonna trigger an alarm every time it gets up to that level. That's a local alarm, both audible and visible, and that's just a notice you can silence it and phone somebody and they'll come out and look after it. As far as, you know, Alex addressed this a little bit too, as far as power consumption. When you put comparable size systems, this beside a lift station, this will actually use less power. It's a very, very efficient pump. It only operates about 20 minutes a day. So you're talking over the duration of a year, probably $20 to $30 in power for a year. So very efficient, very low energy consumption. And if you got a problem, it only affects one person, not 1,000 people.
Just one last question there. So in the end, the amount of liquid you are pushing into the system for final treatment, it's the same volume of liquid, but the BOD is so much lower that you don't have as much treatment
So,
to do.
yeah, so the benefits downstream. So by keeping the solids there, best way I would describe the the pressure mains, they behave like water mains, not force mains, because we're not worrying about solids settling. So when we start talking about, you know, no lift stations, the reason is that we can manage the loss of the friction loss in that pipe. So what that means is we can pump huge distances because it's just like your water system. And the other cool thing is let's say you had a park over here and you wanted to pull off of that, do local treatment and maybe even some reuse. Well, we're not going to affect the collection main. We can pull off it just like a water system anywhere we want. So it really gives you another level of kind of empowerment from an engineering perspective on how you manage these flows and where you send them. And then on the treatment, again, it's less BOD, so that translates into less energy. If you're familiar with wastewater treatment, which a lot of you sound like you are, you know, we're talking about electricity and aeration to get rid of BOD. Well, we're doing it for free, 60% of it. So that means that the tail end when we're treating, we're using less aeration, less energy. In our case, we use an attached growth process, which again kind of raises the bar again. We're not using blowers. We're actually just forcing a draft of air through the system, and the microorganisms get happy because they got food from the wastewater and they got air, and they just sit there and do their thing. So when you put it all together, it's a very, very efficient, passive, low energy process.
How are we on time, Michael?
10 minutes.
10 minutes. Okay. Yes, please.
So one of the main issues that we're facing here on the Cape is not just new build, but having to convert communities that are currently septic to sewer. And I'm curious if you have numbers or case studies that might address that. My concerns being cost to the homeowner on their, because this is a unit on their property, both in terms of installation cost and ongoing operational cost to be powering this. And also those conversion projects for our towns are happening in a phased way, right? And so we have things like force mains that are sized to actually take a whole bunch of additional flow in the future. Can you do that with this system, with it being pressurized, or do you have to go in there and resize shared pipes every time you're adding a new?
Mike, if I could
new
just
area?
start and then I'll hand it over to you. So since we're a new company, we focused on the new homes just because we recognize all the conversations and the history associated with septic to sewer. But certainly there is that opportunity, and we've preliminarily had some conversations on the Cape with some HOA areas where this approach could be utilized. But Mike can talk to the experience with Orenco with septic to
Can you
sewer.
put the graphic there of the decentralized system? So we do a ton of septic to sewer work. We haven't done any on the Cape, but we do them across the country. So I always kind of like to break down the costs, because one of the inherent problems with gravity sewer is most of your costs are up front. You got to build the lift stations, you got deep pipe, you're literally ripping road out, putting it back. So I know here in the Cape, I've seen costs over $100,000 per property to put in a gravity sewer system. We tend to turn those costs on their head a little bit. Is if you focus on the cost to make sewer available, all we're talking about is those small diameter pipes, which about 70% of them end up being 2-inch. They get bigger, obviously, the further that we move the wastewater. But all we're doing to put sewer available is putting in the small diameter pipe. That can be directional board, so we're not ripping up roads. We typically put in the service up to the property line, and then as people connect, we put the on-site units. If you have vacant property, you don't need that unit until you actually build a home. I've actually even talked about surgical phasing, and we've seen a little bit of that in projects. We had one in Florida that used this technique where if people already have advanced systems, they don't have to connect right away. They get to use out their usable life, so it defers that on-site cost. So cost-wise, the cost to make sewer available for a 2-inch pipe, directional board is typically less than $50 a foot, so you can kind of figure out what that equates compared to a gravity sewer system. Again, no lift stations. Lift stations these days can cost anywhere from $200,000 to $1 million. Then on the treatment side, again, we can phase that in and add it as we need it. Instead of building one big plant, you can add it in modular phases. So that cost is typically in the range of $3,000 to $5,000 per home. That on-site cost is generally in the range anywhere from $8,000 to $15,000 all in. We're doing septic to sewer projects, a lot of them in the Midwest and in the South, We're typically $20,000 to $30,000 per home with treatment.
But that might not address the nitrate level that I think that they're trying to get to.
Right, well, so if you're adding nitrogen, the plant gets more complex. Now, again, we may not even, so in our technology, we're doing multiple phases to get rid of nitrogen. So we have to do denitrification on the back end of the plant and adds phases to the plant. There's other technologies, other treatment technologies that we work with as well that may be more cost effective as you scale up.
Is there any issue, I think part of your question too is that you have existing maybe city mains. Is there any issue connecting the PreLOS collection to a city main?
So there is and there isn't. So the wastewater that comes out of this is septic, so it has hydrogen sulfide potential right away. We can get around that by basically we'll aerate it before we discharge, do an open discharge, say into a manhole or something. We can also tie in right into, often into force mains and avoid that. Because the shut-off head on these pumps is so much, we'll actually sometimes bypass that whole gravity system and actually just tie into the pressure system and maintain the integrity of the pressure system. Every situation is a little different, every case is different, but we can adapt to whatever the need is.
So I mean, obviously a town where individuals can work directly with Orenco. I think if 3PO is involved, what we'd love to have a conversation is, let's take one of your phases that's 2030 or 2035. Let's see if we couldn't do a 3PO approach where we would install this, connect to wherever on your town's treatment, and we'd also add the fiber as part of it as well, because as I understand it, there's a need for better broadband on the Cape as well. I know there's regulatory questions and such, but we can talk about it offline if that's of interest, because we certainly have ideas of how to do that. Yes, please.
I've got a pretty clear idea about how the individual home unit works. What about those multi-family or school or whatever?
Sure.
What equipment do you need there?
So typically we scale up the tank based on the flow of the building. Alternatively, we can also use decentralized treatment right at that point. Yeah, so the pods that we refer to, the biggest one's 7,500 gallons. So you can see there's 2,500 gallons, 7,500 gallon. What we will ought to do, instead of actually putting them on the collection system, we'll actually decentralize the treatment right to those sites.
And we have some photos of that as well.
So if you haven't seen these, they look a little different than your normal treatment plant. It's, like I say, it's passive, it's modular. They tend to coexist in very public places, surprisingly right next to parks, and just because there's no blowers running, there's no safety issues. I mean, that one on the left's a little more commercial look. The one on the right is, I'm gonna guess, looks like it's at a park of some sort, but they tend to coexist right in a lot of places you would expect a treatment plant to be.
Yes,
Do you
please.
do any systems, particularly multifamily or schools or whatever, where you have separate black water and gray water systems, and you're using the gray water for the park or the ball field?
We do, and we'd like to do more. So we do have certainly systems, where they're taking water back in, especially for flush water and whatnot. I will say the biggest difficulty in going down that road is cost. You start having public contact capability. It kind of changes the game that you got to treat it to a higher level. You have to disinfect. Some states require us to put dyes in the water, and so a lot of times we start going down that road, and then cost becomes an issue, and they fall back to a more traditional discharge.
Please.
Using textile intermediate to treat it, how long does that last?
So it's just a host. It's an inert material, and it's just a place for the microorganisms to live. In theory, that you should not have to replace it because it decomposes or anything. Yeah, we do have circumstances where a plant is getting overloaded or it gets hit with oil and grease, and that's a different ballpark if they misuse it. We've had to replace it in those circumstances, but not because of age.
Any other questions? Because I think we could talk dirty broadband all day long, but might want to be at 9 o'clock.
You can take one more question.
Good.
Got a couple of minutes.
So, any other questions? Because I just, yes.
How
close to a well can you get with the product?
It's not Title V, so I'm not sure there would be a regulation.
So it's not 100 feet.
So, yeah, it's not, this would not fall under Title V, so,
Because it's all, it's
because
closed.
now it's considered
It's a
municipal.
sealed system.
Correct.
Yes, please.
In the case of Oregon, how much is the cost of, the additional cost of the homeowners to install, and also what about the optics? I know something, like, showing fiber optic offset some of the sewer. I mean, that's what I'm getting, you look at the economics of the homeowner.
Yeah, so for the homeowner, I mean, it's part of the purchase price of the home, because these are new homes, so that they're not really seeing any difference in price. For the developer, I mean, it's 65% less than what they would have done with a gravity and lift stations. So they're able to price it however they want to price it. From a ongoing recurring for Oregon in particular, it's $55 a month per meeting. So yeah, we're very sensitive to that being an issue. Some places that rate would be regulated, so we follow that. You bring up a very interesting question about the fiber. So again, if there's an HOA in the Cape or a new development, we would love to have the conversation of saying, okay, here's this project, and by the way, on the fiber side, we are open to doing a revenue share from our side of the dark fiber rental. That's something we're very open to. So it would drive the cost even further lower for the homeowners in that development.
I'll even frame this another way too. So Orenco's been around since 1981. So we have legacy systems now reaching 40 years of age. The thing that's really distinctive about these technologies is their sustainability. If you look at what's happening across the country in terms of wastewater, it's outpacing the consumer price index by a factor of 2 to 1. And it's largely being driven because, especially in smaller communities, the renewal and replacement cost of lift stations, the treatment plant is huge. And USDA, I think it's about 70% of their projects, to make them affordable, they're putting grant money on it. It's just, everything is pointing to the fact that model might work in really urban areas, but as you get less urban, it's just not sustainable. I can tell you that our systems are 35 and 40 years old, today exist. They don't even have a capital improvement program. You go, well, how can that be? It's because all of the renewal and replacement is part of that O&M cost. So if a pump needs service on property, you go there, you fix the pump, and it restores it back to this relatively new condition. And if you have high quality products, these things just last. And we say we have systems today, $35 a month. They've been around for 40 years, and there's no capital improvement program on them, and no I&I.
And your pipe doesn't go 25 feet down.
It doesn't.
Like all the excavation you're seeing around here, it's just these massive things. Pipe is way down, so you don't have that. So does your pressurized pipe have to be below frost?
It does, yeah. Unless if you do encroach into the frost zone, you can insulate it. So if there's some reason like rock or something that you have to shallow the pipe up, you can insulate it.
Yeah, this is, I think in Maryland on the left, but that's below the frost line. And then you can see, typically when you fiber optic trench it, would look like that. We're just saying, hey, put it in the same trench. Okay, well, thank you very much. Available.